Classes and objects. Python is an object-oriented programming language, and almost everything in Python is an object, having properties and method. A class is an object constructor or a blueprint for creating objects. Classes and objects are very related, they are interwoven, and you cannot use one without the other one. Look at class as a template for making objects. When you are making a cupcake, you will need to put inside a mold. This cup thing that you put, then you put the flour inside a mold, then you put it in the oven, then your cake comes out. That mold that you put it inside is called the class. Then the cake itself is the object. The class produces the object that you need for your program to work. Let's go ahead and see how you define a class in Python. To define a class, you do the keyword class followed by the name of the class, name of the class. So this is how to define a class in Python. Every time it has to be title case. If you notice, functions are always lowercase in Python. So classes are supposed to be title case like this. So you have the name of your class followed by a column. You've actually defined your first class. So let's use a name that makes sense so that we can relate to. So let's create a person class, and you can start declaring the body of the class inside here. Classes have methods and properties. So what are properties? Properties are like the fields or attributes of an object. Methods are actions that you can perform on an object. Notice that we are still in class, so we've not gotten to object, because you can't perform anything on a class. You can just create the model so that when the object comes out, it can now operate. So like the cake example I use, you can't eat your mole. The mole is kind of, I won't say it's useless, but it's what you use to produce the cake. So the class is useful because that's what you are going to use to produce the person, real person object that you want to create. So this person has a property and it has method that you can perform. How do you then use the class that you've created? So let me just write another keyword now. There's a word called pass, and what pass does is not related to class. It's just for us to be able to pass on and go and use this class. That is the main purpose of the keyword pass, and we can use it in other definition, like when we create function, for example. So if we create function and we say function name, so you could actually say pass. The pass allows you to continue with your program without implementing the function, without writing function code. It allows your program to still work. That's the major purpose of pass. So let's go ahead and use our person class. Our person does nothing, but we just want to create an object out of it. We've created the class successfully. This is the design of a class. How do you then create an instance of a class? The instance of a class is what is called an object. When you bring it to life, that is when your object is created. So to create a class, of course, you have to assign the class to a variable, because the class doesn't just exist like that. Yeah, there's some times when you just use the class like that, but most of the time you want to assign it to a variable. So if you don't want to assign it to a variable, you could just use your class directly and just say person. By using this class directly, it creates the object of the class and assign it, and then you use it. It's the same thing by just saying print 5. So look at print 5 and then look at print person. So 5 itself, remember I said almost everything in Python is an object. 5 itself is an object. So if you say print hello, so these three things, they are doing actually the same thing. We are not assigning any of these to a variable. We are just consuming it like that. We are using them. You can then say, oh, okay, I want to use my class for something interesting. I want to create a person object and I want to use the variable and manipulate it. So you can say person1 is equal to person. Just the same way you will say age is equal to 5. You see what's going on here now? You are assigning the person class into a variable. So you can then see what this P is now saying. This P is now a person object. We can go ahead and print our result here. So if you print P1, it's the same thing as saying you want to print person, like I said, the same way we print here. So if you want to assign a variable to it, you can. If you want to use it like that, you can. So this is just testing phase. So let's print and see what we'll have. So when you run this and you print out, you have this funny result. Obviously, it's going to give you a funny result because you've not done any implementation of the object. So let's now start trying to make sense out of the object. What else can we get out of the object? I mentioned that object has two things. They have functions or methods and also have properties. So how do you set properties of a class so that it will then be actualized in the object? For starters, you will say, okay, person must have like a name, and then you want to say the name is James. That is a property and then a value. Then you might want to say, okay, this age of this person is 61. So this is a way to set property, one way, by the way, to set property for a class. But I will show you the proper way to do it. But this is just for starters. And you can actually access the property of a class once you create it. So look at this P1 now. I can say, okay, now I have P1 as an object. Can I access this name attribute? Yes, you can. So once I use the dot notation here, I have access not just to the name, but quite a lot of stuff, but we're not going to talk about all these guys. So the property that you've created, you have access to it. You can say, oh, age. Immediately you run this. Obviously, when you run this, you're going to have 61. And it's going to give you your 61 and things like that. When you create a person, you want to be able to dynamically decide what the name of the person should be. Not that the name should be in the class automatically. This is you having a stamp. Maybe you have a look at the cake example that I use. If you go and use a mold that has another brand name imprinted on it and you create your cake out of that mold, you are going to see that imprint on it. So this is what's happening. So you want to dynamically say, okay, when I'm creating this cake, I want to be able to have the name of my brand on the cake. Now, that will jettison this approach that I've shown you, but this is a very interesting way to set property of a person. And by the way, you can actually change the value of age. So what that means is you can say P1 age is equal to 77. So this can be changed. You can actually change the value, and then when you run it, 77 will be the value. Sometimes you want to be able to create the person with a default parameter. Let's go to functions. Functions are operations that you perform on your object. Most times they manipulate the properties to give you a particular result. The first function we are going to talk about is the function that is called automatically immediately you create your object, and that function name is called init _init_. Yeah, it's funny, but that's what we have and we are going to run with it. How is this function written? So I will clear this because we want to change this approach to another approach, and that is by using the automatic function call immediately we create an object. So immediately you create an object, there's a function that calls, and that function is called _init_. This is the function that gets called automatically when you create your object for the first time. So if you want to use the power of this function, you have to implement that function. Meaning, once you create your person class, you also need to say, oh, I want to use this power of initialization and make use of this to ask the user for age and name. So how do you then make use of it? You do the def keyword. You need to define, because it's a function, you need to implement it. In the implementation, there are some parameters you have to take cognizance of. And the first parameter is the fact that you have to be able to pass itself as an object into this initialize function. So it takes one required parameter and the rest can be the property of the class. First parameter is self. This self can be anything. You can call it anything, but standard wise, you will see self everywhere in other code. So self means that, hey, once I create myself as an object, everything that this object is supposed to have is in self. So this self is the object itself. Whatever the person is or is going to be, this self has the power of it. It has everything in its hand. So you're going to see as we use it, you're going to see what I'm talking about. The next parameter you're going to pass is all the fields that you want to initialize immediately that object is created. So we're working with two properties now, and that is age and name. So I'll say name and age. So those are the two things that we want to set automatically. Immediately we create the object. So then we end our function. Then you go to the implementation. How do you implement this name and age of a thing? So remember what I told you about self. Self has the ability to get all the information about the newly created object. So you use self to accept the value of the name, and you use self to also accept the age of the person. So once you use self dot, look at what happens, guys. It carries all the information about the object. All the information about the object. So you can then specify that, oh, self, I want to actually monitor name, and say whatever value that the user enter as the name should be equal to the name here. And by the way, this name and name doesn't have to be the same, but for purpose of consistency, you can make them the same so that you don't even confuse yourself. So the next thing is you also want to capture the age. So you can do self.age is equal to this age here. So you then have something that looks like this. Look at it again. This should be very easy to understand. The self is mandatory because you want to use it to accept the parameters that are going to be passed when you are creating the person object. And then once the parameter is being passed, it will add it to itself, and then you can make use of it. So let's see the different implementation to this and see how it works. So if you use this person call now, it's going to ask you for two things. Do you see what happens? Look at the way the class is now. Notice that the self is not showing because that self is silent. The one that is prominent is the name and the age. That means that, once you create P1, you can say, okay, P1, the name of the person can be James, and then the age can be, let's say, 25. Automatically, you set the value of the name and the age, and it's being entered into P1. So what then happens is if you print P1.name, you end up having James as the P1. This is a standard function on all classes, and that is initialization. We want to also implement another standard function, and that is __str double_. That is also a weird naming. You will notice that in Python, they use underscore a lot, especially for some inbuilt function, or for most inbuilt function. You are going to be seeing a lot of underscore. So you shouldn't be scared of them. Once it's time to use them, I will let you guys know. And then once you start using them, they become second nature to you. Let's see how we can implement the string function. And what the string function does is that it allows you to convert your class into string. It makes it easy for you to print whatever that it is that you're doing. So let's go ahead and try this out. So just the same way I implemented the initialize function, I can do the same thing for also print function. So I do def _, like I said, str _, and I require to pass myself self so that I can manipulate what is inside myself. Remember, the self is the result of the object that we have. Then I am done with this part. I can then return, I can do string format like this and do my name is self.name self.age old. So let me now show you where the usage comes in, as in how you use it, as in the benefit of doing something like this. So let's say we have this one here. I will now print multiple things. The next thing I want to print is P1. I want to print P1 like an object like this. So if I run this, for example, you then see the result. Look at the result of our P1. It gives you this nice, my name is James, I'm 25 years old, as opposed to if you did not implement it. So let's assume you did not implement this. This was not implemented, and you run this again. Look at what it gives you. It gives you the first result we have, guys. So because when you print out an object, it gives you the object position in your memory. This is the result. This is the string representation of your person object. It can come in handy when you want to represent your object in form of a string. So what are the things that a person should be able to do? For starters, a person should be able to speak or greet. Let's use greet. Let's go ahead and do that. How do you define that information? So you'd use def to define that, and you want to create a function that says greet. And what that does is that it should greet people now. Just say hi or say hello. That's the purpose of this function. So this function is going to be needing some parameter from the self. If you are not going to be needing any of the parameter from self, you might not need to pass any self, any information here. But if you know that you are going to be needing some parameter inside self, you can pass self here as a parameter so that you can use it in your function. So this is me passing the self. By the way, like I said, this can be named anything, but most times you call it self in Python. If you've seen any Python code, you'll be seeing self. So it's like it has become a standard terminology to use. So you'll be seeing us using. So it's not a keyword, it's not a reserved word, it's just a name that you can use to be able to reference to the object that you've created. So here you can then return, or you can just print to the console. I prefer using return because you shouldn't be printing anything in your class. The person implementing your object is the one that should be doing the printing, not inside of your class. So let's return a string that greets. What will this say? So we just say, hello, my name is, just say your name, and that's all. So this is us creating a custom method, guys. All these ones were not customized method. They are part of the power of the class and object. They are something that we can leverage on. So this is you now branching out of the standard and doing your own thing, doing your own implementation and saying greet. Let's go ahead and call the greet. Now that we've set this parameter, you can say, hey, print p1.greet. And then you can run that. So if you run this, for example, it should give you this. Hello, my name is James. Even though after you've greeted this person, now you can come here and say, oh, P1 now is now Michael. And then you can now print and greet again. And it will tell you that, you know, the first time my name is James, now my name is Michael, because you've changed the value of this. That's another thing. Let's move on to what we call inheritance. One of the beauty of object-oriented programming is the fact that you can inherit some properties or some method from other classes. So inheritance allows us to define a class that inherits all the method and properties from another class. So a parent class is a class being inherited from, also called the base class. So the child class is a class that inherits from another class, also known as the derived class. So two things now. So we're about to introduce another class that is going to inherit from this person. So we want to use another example now. So let's say we have another class that is called student. You and I know that student is a person, because if I'm writing this class, student class, obviously I'm going to need the name of this student. I'm going to need to also greet, stand up and greet. They are going to also greet. Why do I need to replicate myself? Anything about programming is trying to make your life easy. You don't need to repeat yourself several times. And class also, one of the way that class try to solve that is through inheritance. So you can inherit other classes that have related information. You can't just inherit any class anyhow. It has to make sense to the object term. A person cannot inherit a car. So you have to inherit something that's related to what you are trying to do. That's why most times when you are creating object-oriented programming, you have to sit down and think very well. You are not just writing the code like that. Because procedural or functional, you can just be writing your code, and it's faster. But object-oriented programming requires you to do a lot of sit back and study the issue at hand and create a proper model of the real life scenario, so that you can properly highlight, oh, this is going to be the parents, this is going to be the base class, this is going to be the class that's going to inherit from this and whatnot. So let's go ahead and start implementing this. If you want students to inherit person, the syntax is a little bit different. So instead of it just happening like this, in a way for you to specify that this student will inherit this person, you have to put a bracket here and say person. So what you've told this class, what you've told this part of the code to do is that students should inherit person. So we can then use our pass keyword there to just pass and skip any implementation. Automatically, what you've done now is that everything that person has, students also have it. All the code that we wrote that targeted only a person can also be targeted against students. So let's go ahead and create a student. So I'll say S1 is equal to student. The name of the student is Janet and she's 18 years old. You can see this is practically the same thing we did for person. So let's now say P1 is equal to person, and this one is James and this is 25 years old. Nothing different. The only thing that is different is that we've used another name to call this object because we've not implemented anything special in the student part, and we're going to talk about how to implement special things for that, but gradually. So now if you run this code, it just gives you the same result, apart from the fact that you've given it a different implementation. Let's say we then want to implement a function for greet. The greeting of a student should be different from a greeting of a person. So this person is just general person. We're not being specific. So this student's greeting should be different from this person's greeting. And to do that, we need to implement the greet inside the person. Remember that the person is like the parent class. Is the class that rules everything. So let's go ahead and do our define class for greet. And because we are going to be using some part of the implementation, this guy will need to have self. We just want to change the wordings the way this person greets. I will say, hello, my name is self.name, and I don't need the age, and I'm a student. So that should do. Now, what do you think will happen if we do print S1 greet? So S1 should greet, and also we want a normal person to also greet. So if we run this, we have the first one says, hello, my name is Janet, I'm a student. The second one says, hello, my name is James. You can allow other classes to inherit person, not only just students. So because it's possible that we can have another class called teacher that will also implement from person. So you can go on and on and on, depending on the level of complexity that you are approaching. It's not must that you have to inherit anything by default. It's only when they are related that you want to inherit those things. And like I said, it makes code very easy. So you can see that I've been able to implement greet, differently from the greet of the person. And because this is a teacher will greet, differently as well. So I can come here and do the same thing, but this time around, I will say I'm a teacher. So I'm going to leave that there and go to the next thing I want to implement. So let's write for teacher implementation here, and Mr. Okoro maybe he's 40 years old. Another thing that you will notice is that we are using the standard initialization of the person, but you agree with me that it's not all initialization that will really matter. So what do I mean by that? Teacher, for example, you might not really need to know the age of a teacher. It's irrelevant in the implementation of normal software. What you want to know about a teacher is the course that he teaches. Same thing with students. Yeah, even though I agree that you might want to know the age of a student, but you are more concerned about the class that the student is, maybe JSS1 or something. So how do you specifically say that, oh, this student object, this is what I want you to focus on? So, and how can you do that is by implementing the initialization method for each of the classes. So we can start off with students. So let's go to students and see how that works. So it's a little bit different. So first of all, let's call the initialization method, and that's by using def double underscore init double underscore, and then you pass in your parameter. So you should know this by now. You need to implement self because you're going to be setting some information inside there. You set in the self. The next thing that follows is that you will also be passing in the name and everything that's important for this person. So yeah, if you want the age, yeah, age is important. You pass in self, you pass in age. Remember the last thing that we say we want to capture for students. We now want to capture the class. Well, don't confuse that with the class here. So the guy is even confusing it already. You can see that it has changed the keyword. So we can say level. Then here we can then do here and come in here to define what it is that we want to do. Remember, to be able to capture these two guys, look at what the parent class did. To be able to capture these two guys, we did self.name is equal to name, then self.age. So we now do the new one, which is level is equal to level. So this is now the new thing. But instead of you doing this, you can see some repetition here. There's a way to solve this, guys. This is a repetition. This is anything that has to do with repetition, try as much as possible to avoid it. So this is okay, but there's a better way to do this, and is by using a function called super. What super does is that it targets the parent class and implements the initialization function of the parent class. So this can be denoted by saying super and then dot. You can then call the initialization function of super, which is the same thing as person. How do you call it? You do double dash init double dash, and then you can call this function by just passing name and the age. And the reason why you have to do it this way is if this person implements some weird coding, because it might not just be only setting, it can do some function call, it can do anything, because we are just doing it this way. What if it's going to open a connection to a database, or is checking a statement or something like that? So, and you can't repeat that same process here every time, but you have an access for you to call it. So you are calling that function inside here directly. So it's doing the initialization, and then once it does it, you can now implement your special initialization for students, and that is by setting the level. The same thing we've done here, we can repeat that same thing inside what? Inside teacher. So I'm going to duplicate the whole thing here, but instead of level for teacher, we can then say the course that it teaches. So we'll say course, and we'll change this one to course. So I leave this one like this, constant, because of the fact that this can be doing some miracle here. You can be doing any gymnastics here, and this properly implements whatever gymnastics that you are doing here. So because it's not just only variable you are setting here, you can be doing some other things, you can be manipulating some other things there. Now that this has been done, that gives us more room to express ourselves in our grades. So let's start with the students. I can say, hello, my name is so, and I'm in whatever level, and I'm in self.level. I'm now using the parameter that has been passed from, while initializing it. So I'm not just depending on the name and age alone, I'm using other things. Even though you're passing the age, I'm not worried about the age. What I'm worried about is the fact that you're a student and this is your level. So here, hello, my name is so, I teach so course, self course. So let's give that a run. So if we already have teacher 1, so I call this T1, S1, this that, and then you can go ahead and do T1, and then if you run it, you should have an error. So we did not implement the parameter. Like for example, now the teacher, we did not pass the course. Let's go ahead and pass the course that it teaches. So we can say it teaches maths. This guy is a student, and what else was his level? Let's say 200 level. And the person does not need extra parameter to be passed. So let's run it again, and we have another error. Really, Okay, so teacher attribute has no attribute cost. Where is the cost guy? Okay, so do you see our error? So this is our error here, guys. Line 24. So we copied and paste. We did not rename the level. So you can see the reason why I told you that your name of the property does not really need to match the parameter, but for consistency, you match all those things so that what you are saying is what is happening. So you have that, and I hope that's all the errors we have there. Let's run it again. Okay, that's all our errors. So we have hello, my name is Janet and I'm in 200 level. My name is Mr. Koro. I teach math course. My name is James as a person.